Hello friends, I welcome you in lecture number 6 on applications of integration. In this lecture also we will discuss one more problem on disk method, and here we will consider rotation about y-axis. So we understand this question: find the volume of the solid which is obtained by rotating the region bounded by y equal to x cube, y equal to 8 and x equal to 0. So first we sketch the region bounded by given curves. Here we are having y equal to x cube, y equal to 8 and x equal to 0. So suppose these two are coordinate axis, and now we consider y equal to x cube. We are familiar with the shape of this y equal to x cube. It will look like this. Let me sketch properly. Y equal to x cube is the curve which is symmetric about origin. We are interested in the region bounded by y equal to x cube, y equal to 8 and x equal to 0. X equal to 0 means y-axis, and y equal to 8 is the line parallel to x-axis. So we consider this much distance as 8. So this is going to be y equal to 8 if this distance is 8. And region bounded by y equal to x cube, that is this part is y equal to x cube, y equal to 8 and x equal to 0. This is y equal to 8, this is x equal to 0, and this is y equal to x cube. So we have these three boundaries. So this is the region which we have to rotate about y-axis to generate this solid, and that solid is called solid of revolution. So we can roughly sketch the solid which will be generated by revolution of this with respect to y-axis. So first we again consider this x-axis and y-axis, and now we try to imagine, or we try to sketch the rough sketch of the shape of a solid which will be generated by revolving about y-axis. Here the rotation is about y-axis, so we will consider rotation of this region about y-axis. So for that, as I have discussed, if we want to sketch the shape of a solid, we have to take mirror images of these boundaries. Here we have y equal to 8, so here somewhere I consider this is y equal to 8. So I have to go up to this point on both sides. We assume this same distance on both sides. Then I consider mirror image of this part of y equal to x cube parallel to y-axis. So here we will have this type of shape. We are considering mirror image of y equal to x cube with respect to y-axis, so we may have this type of shape. Okay, let me sketch it properly. So we will have this type of solid which will be generated by revolving this region about y-axis. Now to find out the volume of this solid which is generated by revolution of this, we consider the cross section of this solid perpendicular to y-axis, and we know that cross section will be a circular disc, and it will look like this circular disc with some thickness, say delta y, and radius of this circular disc is nothing but value of x. So this is going to be radius, and it is a function of y. Here we have this distance which is x, so we require x in terms of y, so that we can obtain from this y is equal to x cube. So therefore x is going to be y raised to 1 by 3. because x this distance is positive, we will consider x equal to y raised to 1 by 3. So this is the radius of this circular disc, which is the cross section perpendicular to y-axis for this solid. So now once we obtain the radius, we have to consider limits of integration for variable y. So y starts from y equal to 0 and we have to go up to 8. So we consider limits of integration for variable y are from 0 to 8. And now we can find out the volume of the solid generated, volume of the solid which is generated by revolution about y-axis. So volume of the solid of revolution is denoted by V equal to y from 0 to 8 pi into x square dy, and x we have converted in terms of y, so we substitute value of x here. X is y raised to 1 by 3 and we are taking square of 1 by 3, so it is y raised to 2 by 3 integral with respect to y. So now we can take pi outside. Integral is going to be y raised to 2 by 3 plus 1 divided by 2 by 3 plus 1. Limits of integration for y are from 0 to 8. Now 2 by 3 plus 1 is 2 plus 3, that is 5 by 3, and 5 by 3 is in the denominator, so that we can rewrite as 3 by 5 y raised to 5 by 3. Limits of integration are from y equal to 0 to y equal to 8. Now this is going to be 3 pi divided by 5. Upper limit is 8, so we consider 8 raised to 5 by 3 minus 0 raised to 5 by 3, that is going to be 0. Now we can rewrite 8 as 2 raised to 3 and power is 5 by 3. So we can see we obtain 3 pi by 5 into 2 raised to 5, and 2 raised to 5 is 32. So we have 32 into 3, that is going to be 96. So we have 96 into pi divided by 5. 32 into 3, let me check again, I am not good at this type of calculations. So the volume V is 96 pi divided by 5. So this is another example for the volume of solid obtained by rotating the region about the y-axis. Here rotation axis is y-axis, and therefore we have this type of circular disc with radius x, and we find out value of x from this, and we obtain that volume is equal to 96 into pi divided by 5. Okay, fine. So this is all about this session. In upcoming lectures we will consider rotation of the region about vertical lines or horizontal lines different from x-axis and y-axis. That means we will consider the rotation about lines which are different from x-axis and y-axis, and we will see how to find out volume of solids in those cases. So this is all about this session. I hope you like it. Thank you very much.